So welcome back to the second part of SVM. What we have left from previous part is the method called grid search. And we know that it is an idea of creating a grid of parameters and just trying out all the possible combinations, right? And this is a common method, a built-in helper function in a scikit-learn library. Its name is called grid search CV. The CV stands for cross-validation. Okay, so grid search CV, it takes a dictionary that describes the parameters that should be tried and a model to train. Where the keys are the parameters and values are the settings to be tested. Okay, so what does that mean? Let's take a look. So first, I'm going to declare a variable that represents a grade of parameters. I'm going to call that param underscore grade, and it will be a dictionary with parameters. So what should be my key values? As I said, key values should be parameters. If you scroll up, and if you have some statistical background, you might know for SVC model, the key points will be C value and gamma value. If you have a larger C value, you will have a lower variance. But always remember, there always will be a trade-off between bias and variance, right? So that's why we need this grid search to help us to find the best fit for C value and for gamma value. Okay, so first key value will be capital C. So what number should I put here? Let's just try out this one, 0.1 to 1 to 10 to 100 and to 1000. Okay, and second key value will be gamma, right? And it could be a list of numbers from 1 to 0.1 to 0.01 to 0.001 and to 0.0001. And the last parameter, the last key value will be kernel. Okay, but for this one, I'm gonna just leave it with default, so RBF. So we have declared this variable, param grade. Okay, now it's time to import the method. So from sklearn.model selection, let's import this grid search CV and instantiate this grid search CV, and just declare a variable called grade and pass that to the grade variable. Okay, so if we read the documentation, you can see here are so many arguments that you can pass in. And what is my favorite part about grid search is that it is a meta estimator. What does that mean? So it can take an estimator, just like SVC, and creates a new estimator. So and that new estimator behave exactly the same. So in this case will be a classifier, right? And what we should do here, we should keep this refit equals to true. Okay, and also select variables to whatever number you want. Higher the number, the more variables. Variables means the text output describing the process. Okay, so let's pass in the arguments. The first one will be my SVC model. And second, a list of a grade of parameters. So param grade. Okay, and refit equals to true, or you can leave it as default. The default is true, right? Variables equals to. So Always remember, don't leave variables to 0, okay? Don't leave it 0. Pass some numbers to that, maybe number 3, okay? Otherwise, you won't see the difference, okay? And then let's fit this grade to my training data set. So X train, Y train. If you have a big data set, this process will take a bit longer, okay? And if we go back to see this fit method, this fit method is a bit more involved than usual. So first, it runs the same loop with cross-validation to find the best parameter combination, okay? But once it has the best combination, it runs fit again on all data passed to fit, okay? But this time without cross-validation, okay? It's to build a single new model using the best parameter setting. Does that make sense? Okay, so now we can inspect the best parameters found by grade search CV. Okay, so let's do this. What should be my best parameter? Grade dot best underscore params. Okay, this will give you the best parameters the grade search CV found for us. So C value will be, the best C value will be 10, and the best gamma is 0.0001, and the kernel as RBF the same. Okay, so if you want, you can also take a look of the best estimator, okay? So then what we can do is rerun the predictions on the grade object, okay, just like what we have done for the normal model, okay? So grade underscore pred grade dot predict, predict, and pass this X test. Oh, sorry, I have a typo here. And next, let's print out the result. The first one will be confusion matrix related with Y test, and also my grade prediction. Okay, and second one, classification report. Same thing here. Yeah. Perfect. So here we can see the result. Okay, for the precision, for recall, and for F1 score. The average here will be around 95%, which is pretty good. Okay, after we adjusted the parameter, after we find the best parameter for this SVM, right? Okay, so today we've talked about how to train a SVM model, and also how to use the grid search. Okay, that is important. The grid search, you're gonna use that a lot in the future. Okay, so don't forget to do the project. So I will see you next time.